So welcome everyone today to this presentation for the Data Science Virtual Group for PASS. Glad you're here today. We have a speaker here, and before we get to Kevin's presentation, I have some general slides to show about PASS. The PASS Summit pre-conference call for speakers is now open. So this is going to be an event for the pre-conference. I think that's all virtual, so that's all online. So no matter where you are, you could be a speaker for this. It's just an opportunity for that. PASS Educational Program Survey is open. So they want to ask you as a PASS member, what are you interested in seeing in terms of content? And then they also have an enticement that they will give you a free registration to PASS Summit, which will be in November, if you submit this before March 3rd. So there's a few days still left. If you want to do this, you can shoot that code. And again, this will be on our recording, so you'll be able to see that later. PASS Partner Webinar. We're going to have a webinar from one of our partners here. DataVail will be doing something for that. Early bird pricing, and that's possible now to go into the platform, registration platform, and register for this conference. This year, we are having this conference in Houston. In the past, it's been in Seattle, but this year it's in Houston, and it's going to be November 10 to 13. Some of the upcoming presentations, some of these are in the past. Okay, we're ready at the 27th, and this deck was done, several weeks ago. But even today, we have a presentation on cloud, DBA in the cloud, and another one a couple days in SQL. Where you see these webinars is on the PASS website, and you can see what some of the talks are for these upcoming presentations. Kevin Klein is one of the long-term speakers, personal friend of mine. I've been to his house in the Nashville area, and he's gonna be talking on habits of highly successful DBA teams. That would be great. And we got a lot of great speakers, really, on a lot of these talks rolling into March. A lot of the groups will try to organize this long in advance so that you see what some of these topics are as they're coming up. There are a number of groups, and if you opt in to these different groups, you'll get notices directly when those programs are scheduled. SQL Saturday is an important conference for PASS, and I've been a speaker at many SQL Saturdays in the past. In the coming month, February 29th is going to be this weekend, and we got events coming in Tampa and Rochester, New York. And then rolling into March, we see events across the US and different areas. And Canada. I guess we're all rolling as one area because Victoria's in here. Chicago's, so which ones have I spoken at? I spoke at South Florida and in the past, and Spokane, I think I did speak it there, and at Chicago, yes, not Cincinnati or Boston, but that's something I've enjoyed doing in the past, and also open to you to do as a speaker. A lot of these conferences are looking for speakers for SQL Saturday. And by the way, sometimes I've even joined as a last-minute speaker because people drop out. So sometimes you can send the organizer your email and say, hey, you do any spots, like 2 days before, and they may have one. Career Center, these are people for looking for jobs or also recruiting for talent. We have so much talent inside the PASS organization. Even there's thousands of members have joined this group. And the PASS is very available on various media, social media. Just letting you know about that. Okay, so now we're going to go to our talk for today. And for that purpose, I am going to switch over to screen and change the presenter to Kevin, who is a MVP. And Kevin, your screen should be coming up. I think everyone can see that. SQL Server Machine Learning Services in Production. So Kevin, you got your audio on?
Yep, let's take it away.
All right.
So, hello everybody. Welcome to SQL Server Machine Learning Services in Production. My name is Kevin Fiesel. I run a predictive analytics team out of Durham, North Carolina. I'm also, like Mark mentioned, a data platform MVP, and I have a blog called Curated SQL. The idea of Curated SQL is that I want to try to find and link to 5 to 10 interesting posts per day on topics like database administration or development, R, Python, Hadoop, Scala, Spark, Power BI, reporting services, security, or anything else in that broad data platform space. So that's curatedsql.com. Also, just about a month ago, I had a book published, Polybase Revealed. If you're interested in Polybase, especially in SQL Server 2019, go check that book out. Buy like 50 copies. But let's talk about machine learning services. This was originally released as SQL Server R Services, came out with SQL Server 2016. In 2017, Microsoft added support for Python, renamed the product to Machine Learning Services. With 2019, Microsoft has released support for Java. So in today's talk, I'm going to focus on R, and I'll talk about how Python is almost exactly a one-for-one comparison. We're not going to talk about Java today. What I want to do is introduce you, if you haven't seen it before, to SQL Server Machine Learning Services. Regardless of whether you've seen it before, I want to talk about principles that I like to follow with my team for managing these external packages, deploying custom code, basically maintaining an actual business product that relies on machine learning services. In the process, we'll talk a little bit about security and give you some tips on managing your servers that have machine learning services installed. So that's my agenda in short. The first step I'd like to talk about is installation. Start with a new installation, either standalone or add to an existing installation. And we have a couple of options. You have immediate option available to us. In instance features, I have one section boxed and one section that says probably don't want to do this. The in database machine learning services means I'm going to be able to, from a T-SQL query, call out to R or Python if you check those boxes. Now, you can install machine learning server as a standalone product. In the event that you don't have a SQL Server instance available for this, or you want to have it completely separate from your SQL Server instances, it is possible. I won't get into licensing, but you would have to license those instances separately. I would highly recommend using in database because a huge part of the benefit of machine learning services is simply that it allows you to send your code where the data lives, because you've probably got a lot more data in terms of size than you have code, unless you're using Java. Then that's giant jar files. After you've gone through and installed, go to Management Studio, Azure Data Studio, whichever, and enable external scripts. So it's a config setting, SP configure. We run that, reconfigure, and then we have to restart a service. Restart the Launchpad service in SQL Server. So you'll have your database engine and a few other services depending on what you've installed. The Launchpad is how we can reach out to that remote R and Python code. So I'd also recommend restarting the SQL Server engine while you're at it, just because it's a Microsoft product. Restarting it usually helps. So we've got this thing installed. The next question becomes, well, what do we actually do with it? And immediately, if you're working with developers, they're going to want to install packages. They'll want to bring in third-party code because that makes life so much easier. Well, we've got some considerations to think about when installing packages in R. Like, which version of SQL Server are you using? So if you're using 2016, you just can't do Python at all. If you're using 2017 or 2019, we have the options R and Python. The way that we're going to install packages will differ based on the version. If you only have 2016, certain tools will be accessible to you. Other tools will be a little bit more difficult to work with. If we've got 2019, security models have changed a bit so that some of the stuff you could do in prior versions, you're not going to be able to do anymore. If your servers are completely locked off from the internet, then some of these options will not work and we'll have to try other things. So there's a set of trade-offs in each of these that I'm going to talk about. The first thing I want to cover is, frankly, my heavy recommendation if you're using SQL Server 2019 or SQL Server 2017, and that is the SQL ML Utils package. The first demo I'm going to show will go into this product, and this is, I think, the best way to install R or Python code, whether that's your own custom code or a third-party library that you're grabbing from CRAN or from a Python repository. But it's not the only method. If you have administrative access to your server that is running SQL Server, you can open up a console and run install.packages in the console itself. I've had to do this for certain things like installing Keras and TensorFlow in R because MLUtils didn't like it very much. So it's not something I would generally recommend, but it can work as a fallback option. You can execute scripts, including install.packages, using sp-execute external script. This is the command that machine learning services gives us to be able to run our Python or Java code from T-SQL. But it only works for installing packages in SQL Server 2016 and 2017. The application model, the security model, has changed for 2019 such that from sp-execute external script, you're not going to be able to install a package on your SQL Server instance. So you'll have to use a different technique. Rx install packages is a wrapper that Microsoft ML has for safe installation of packages. It's a wrapper for install.packages. Does a little bit more, and the same rules apply. You can use that in an admin console from your server. You could call it prior to 2019 from sp-execute external script, but again, just like install.packages, this isn't going to work for 2019 and later versions as they eventually come out. What can work if you're in T-SQL is create external library. So if we have a library somewhere, I have a zip file, for example, that has my R package, or I have a wheel file that has my Python package, I can create an external library and either make it available to everybody by making the owner DBO, or make it available just to myself. And a benefit to that is each one of the data scientists on your team may have different versions of packages, and this is going to allow you to segregate those versions of packages by person. If you're totally locked down, you cannot get to the internet from your SQL Server instance, you won't be able to install remote packages. You can use a tool like mini-CRAN. So CRAN is the Comprehensive R Archive Network. It's going to allow us to basically pull in a bunch of third-party libraries and enhance our R code without having to write quite as much code ourselves. Mini-CRAN is a small version of CRAN that is installed on your own servers. So you select which packages from CRAN you're going to pull, you select what versions of them you're going to have available to you, and instead of pointing your servers at CRAN over the internet, you can point them to this local server. So if you're familiar with managing, say, something like a local NuGet repository or just any sort of local repository, this is the same idea. There are a couple of other options if you're absolutely offline and can't do anything else. In that case, probably create external library is going to be your best option. With older versions of SQL Server, you could also take the zip file and run install.packages locally. even with 2019, you can run that from an admin console. If you have the packages downloaded, you have all the zip files available, you can install that packages that way. So at least a half dozen available options for us, but the one that I would most highly recommend in almost every case is this one right here, SQL ML Utils. So I have all the code is going to be available to you. I'll give you a link at the end of the talk today, but installation instructions are available, and you can get more details on what SQL ML Utils does at their GitHub repo. So this is a product that is developed internally at Microsoft. They've got a GitHub repo. You can try it out. You can submit issues. I've submitted a couple of issues. And once we get things installed, I'm going to install our ODBC. We're going to make sure that that's already set up. So I can run this and it says, okay, nothing responded. It's already installed. So I can also try to install SQL ML Utils, but I already have it. So let's just hop straight to the library. I'm going to need to do this for every database. I'm going to need to connect to the database using my ODBC driver. I'll connect to a local host, and the database is called Scratch. So that's my database connection. Once I'm connected to a database, I can install a package to that database using SQL_install.packages. So notice the naming is very similar to the R naming, except that they put SQL_ in front of it to tell you that this is intended to go to a SQL Server ML Services installation. We'll connect to that database, localhost.scratch, and install the tidyverse package. So the tidyverse is an opinionated series of products that is intended to get you to well-normalized, well-formed data. There are, by last count, I saw 78 separate packages that get installed as part of the grand package tidyverse. I've already done this morning, so it shouldn't take too long. It shouldn't have to go grab all 78 of them and install them independently, but we'll see how long this takes here. I can scope my package installation as either public, which means everybody gets it, or I can make it private, which means that only I get it. I'm going to leave this as public. It'll be owned by the database owner. And as a result, any user is going to be able to grab this. It gave me a warning, but that warning is okay. Basically, it says you've already got this installed. And by the way, there's a package that is older than the version available in the repos. Like, that's okay. We're not going to worry about that today. I saw that message, all these messages, because I set verbose equals to true. So I don't have to install just one package. I can install a whole set by setting packages equal to the combination of forecast, WKB, data table, and zoo. So that way I can install several of them at once. By the way, this is a rerunnable installation. You saw that I did that with tidyverse. It succeeded. Now, in its success, it told me that stuff's already installed, but that's great. That means that I can run this as part of a release script, and even if a package is already there, it's not going to fail my release. So that's a very nice feature to have here. I don't have to write a bunch of code checking to see if a package already exists, and if it doesn't, then install it. This already does that for me. If I do want to remove a package, it's as simple as calling the remove.packages command. Once again, I'll pass in a database connection, the list of packages to remove, and the scope from which to remove it. Because I may have a public version of Zoo, but I might be trying out a private version of Zoo that's a later version and making sure that it works with our code. And if it does, I can uninstall my private one. I can uninstall the public one and install the latest version for public. So we're grabbing packages, moving them over to SQL Server, and installing. You do need the appropriate permissions. You have to be able to install packages on your remote SQL Server instance. So make sure that those security settings are appropriately set up. But one other thing that I'll point out is that I'm installing this from my laptop. The SQL Server can be on a remote instance. So it could be that my build server, the thing that has SQL ML utils, can access the internet, can pull down packages. My SQL server doesn't need to have access to the internet, because what's happening is I'm downloading the packages locally to a path, and then I'm sending them over to SQL Server separately. So this gets around the issue of I don't want my SQL servers connected to the broader internet. So that's another nice bit about SQL ML utils that makes it a viable option in a lot of cases. I can check what packages I have currently installed by looking at installed.packages. And I've got a few fields that I'm going to pull back. So as soon as it returns, we're going to see what those fields look like, what that data set looks like. Should take just another couple of seconds. I've noticed that this is a little bit of a slow command. It will take a hot minute to finish up, but
Kevin, quick question since we're mating.
yeah.
Did you authenticate through a SQL Server login?
So did I authenticate through a SQL login? In this case, I ended up using Windows authentication,
Okay.
but you can authenticate through a SQL login as well.
Okay, and then just asking because I did not know that package sharing ability, which should be true because you are authenticated to be able to load those packages. I didn't know about that.
Yeah, I haven't been able to, or I haven't had the need to look to see if I could make that a totally different user, because to date, my team has only done public,
Okay,
because
but
we want everybody running on the same set of packages for development.
right. Okay.
All right, let's view. So here's my grid of packages that have been installed. Most of this came as a result of installing tidyverse, but we can see the scope. All of this is public so far, but I've got all of these different things. I also have system packages. These are the things that are installed with SQL Server. So we already get Microsoft ML. We get some of the stuff that's been built into Microsoft machine learning for the past few years, as well as a few really deep in the core of R packages like Mass and Lattice. So there is some nice stuff that's there automatically, and the rest of it is things that I have installed. Either you watched me install it right now, or it came with tidyverse that I installed just a little while ago. This also will work with your custom packages. So if you've built a package, it doesn't have to come from CRAN. You can just take it from a directory someplace. So this will work on a UNC path. It'll work on, in this case, a drive path, which means I don't have to have it like physically on the server. I could put it on a share, and again, have a build server pick it up from wherever the share is, or whatever generated this artifact, and then ship it over to SQL Server. So post installation, welcome to machine learning services. We're going to call SP execute external script with our language. My language of choice today is R, and my script, just to make sure things work, I'm going to print out hello world to the console. There we go. It just wanted to mess with me because it knows I'm presenting. So we get hello world written out. Life is good. I can go to my database and look for all of my external libraries that are installed. And some of these names should be pretty familiar because we saw that in the R data frame. And I can use these external libraries. So in this case, I am going to load up tidyverse and build up the list of 1 through 5 and use the pipe and magrittr to sum up the values of 1 through 5. Is not the most efficient way of performing the summation, but what it does allow me to do is show loading the tidyverse, and we get to see these warnings from tidyverse that says, hey, if you load dplyr through library, it's going to mask the filter command in stats So if you call just filter without specifying your namespace, you're going to get dplyer's version. It'll also spit out the end result of this, sum of 1 through 5, which is 15. Now these are per database, like I mentioned. So if I switch to a different database altogether, I am not going to see my external libraries. And if I try to execute a command, I'm going to get an error here that reads, there is no package called tidyverse. This also will happen if your permissions are not set up appropriately, where, for example, if I deployed the library as a private library instead of a public library, other users are going to see this error message, even if your code will run successfully for you. And you'll know whether or not the library is set up, if the principal is set up appropriately, because by querying sys.external libraries installed, you'll see the principal here. So you'll know who it's set up through. And in this case, it's DBO. Okay. Very briefly, also, I guess I'll show demonstrating installation using create external library. So we'll use the Scratch database. Do I have something called Benford analysis? I currently do not have a library installed, Benford analysis. If I did, I was going to drop it. But because I don't have it, let's create it. The content is going to be this location. So I've got a version of Benford analysis, hopefully in this spot. The languages are, let's see if it works. Select from sys external libraries. And let's do this. There we go. We now have publicly scoped Benford analysis. Anybody's going to be able to access this at this point. So great. Packages are installed. Those are third-party packages more than custom code. But when it comes to code management, you can put your code inside SPX execute external script. But this is like dealing with dynamic SQL, with SP execute SQL, where you can do it, but quickly it becomes an overwhelming problem because it's going to be hard to maintain. You've got all of this code that's wrapped around single apostrophes, making it hard to see. It's hard to debug. If you have syntax errors, it's not going to be that easy to tell because it's all just one giant string. So I would highly recommend segregate your R code, your Python code, as much from your SQL world as possible. And I liken this to dependency injection in the application development world, where instead of linking together my database queries and my application code, I instead say, here's my app code. I'm expecting a repository called whatever repo that has a method that will give me data shaped like this. And at runtime, I can plug in my database. In unit tests, I could mock the database. So that way I'm not tied to a particular implementation or a particular instance of a thing. In this world, it's pretty similar, where I've got a package and the contents of that package can change independent of my T-SQL code. So I'll show you what that looks like. I want to create a reference library that's got my code. I think for data scientists, development in a tool like PyCharm or RStudio or even Spider, it's a lot easier than giving them SQL Server Management Studio and saying, here is your integrated development environment. Debugging our code is so much simpler to do outside of SQL Server because I can run through this, I can build tests, I can use test that, I can use assertions, make sure that everything's looking good, and then I can package it up. And packaging also lets me maintain a code history a bit better. I have different versions of the packages. I can store those, archive them. All my code can go into source control repos, and just make it easier for me to follow good development practices. So let's dive into the demo here. This will be the first part of a slew of demos on code management. So I have a tutorial. So Microsoft has a tutorial on ski rentals, and I liked that tutorial so much that I took the database, restored it to my local SQL Server instance, and it is called Tutorial DB. From there, I'm going to start running some queries. So let's create a table, rental RX models. We have nothing in that table so far, but we're going to put in models. So the model will have a name, which is a string, and the var binary, which is the contents of the model itself. So it's a serialized version of the model. When we generate a procedure, I want to drop it if it exists, and if not, create the procedure. Or I could say create or alter procedure. Yeah, I could do that as well. But we are going to pass into SP execute external script the following command. Select various data from rental data where the year is less than 2015. And if I look at that, I've got some input features, and I have my label, which is the number of people who rented on that day. So we've got some inputs. Hopefully, we can relate the inputs to the number of people who rented. That's a little orthogonal to what we're talking about today, because specifically today we're looking at management as opposed to building great models. SP execute external script is going to take in that SQL statement as its input and call that rental train data. So you'll notice I'm referencing rental train data a few times here. I load up RevoScalar. I set holiday, snow, and weekday to be factors. And then we're going to build a decision tree model using RevoScalar's RxDTree function. And that will build a decision tree where we try to explain rental count based off of all of these features in our training data. And that's going to give me back a trained model that I'll call model dtree. And we need to serialize model dtree and then save it as binary. So that'll be called trained model. And you'll notice in parameters, I expect to get a trained model back as my output. So that's what I end up getting. Take this thing, we'll truncate the rental RX models, which is already empty, generate our model for a binary, and then insert the value into rental RX models. So this takes a moment to run through to do its processing, and it spits back out some binary. I can take this binary, I'm going to deserialize it. I'm going to be able to generate predictions based off of that later. So let's look at that prediction procedure. This prediction procedure expects me to send in a model name and a query that includes the data that we're going to pass to machine learning services to predict. So let's look in rental RX models for that particular model. We're going to use RevoScalar again. And what I need to do is take that new data from input data set. So let me explain how I got the name input data set. In this demo, we have input data 1 is a SQL query, and input data 1 name is something. In this procedure, input data 1 is a SQL query. That SQL query is what I'm going to pass in, but we don't have an input data 1 name. So by default, if you don't have one, it's input data set. So we're going to call that rentals internally and set the same stuff that we did in training. We have to do that with whatever test or production data we have. So we've got to make it look the same. We're going to unserialize our model, which deserializes it. And we're going to call that rental model. Finally, use the predict function off of rental model based on our rental data set to generate predictions, put it into a data frame called rental predictions, and we're expecting rental predictions to come out. So we'll get back this result set of rental count predicted. So it's only one value, and it will include the actual values of the predictions. So we generate predictions. I can build out a RxD tree and run this for a row, and we'll get back that we would expect this many people to rent based off of our inputs of month, day, weekday, snow, and is holiday or not. Okay, so to this point, we've worked with machine learning services a little bit. We've loaded up some packages. We've written our own code. But I think that there are a couple of things that we can do to make life better. First one is to isolate these external script calls. So here's what I mean. If I pop back to my procedure, I have a procedure that I'm expecting maybe the application will call. And that procedure calls sp execute external script. So what I tend to like to do is wrap this inside another procedure. So I'll have maybe predict rental count R and then predict rental count that calls predict rental count R. That way I can call, if I'm debugging, I can call the procedure that generates R code and it will just return back whatever data frame I expect. In my outside procedure, my wrapper, that's where I can do things like take those results, put them in a temp table, and then merge that data into an existing data set, or join to other tables and perform further work. So this is the quote production unquote procedure that does what we're really interested in having. And then the internal procedure exists as a means of making sure that I can troubleshoot easily. When we're working with R and with Python, there are a few places that I'm able to store models. So I can store my model inside an R package. I can put it on the file system. I can put it inside SQL Server. We just saw method 3, loading in a SQL Server in a table. And I know that as a database administrator, you might be thinking that I don't really want to load a bunch of binary data in a SQL Server. I mean, we had that debate 15 years ago with why don't we put images in SQL Server and store all of our images there? And the answer is it's not a good place for them. And to an extent, I can agree. But it's not quite as bad as loading a bunch of images in SQL Server. There are actually a couple of benefits that we're going to get if we can store models in SQL Server. But if you have something that's really big, like for example, I've got a model that uncompressed is something like 120 some megabytes of just weights. It's not going to fit in SQL Server very well. So instead, we've wrapped that as part of the package. So we install a package that has the model like in the same directory. It's readily available to R. You can put it on the file system, but SQL Server 2019 really locks down what access is available. So you'd have to grant special access to get to the file system to read those models. Also, there's a part of me that's a little squeamish about storing a bunch of data on a SQL Server system, like something that's on the file system of a machine that's intended to run SQL Server, because if you run out of disk space on accident, you can have catastrophic consequences for your SQL Server if you don't have things laid out the right way. So I'd rather just have everything be in SQL Server or in R packages. That said, if you have a strong opinion that you really want them on the file system, you can still do that. When it comes time to update your packages, hey, you've built this package, you want to release a new version, you can't be running your code at the time. So if I have a process that may take 5 or 6 hours and I'm in hour 3 of it, I cannot upgrade that package while somebody's running code that uses that package. What'll happen is if you try to remove the package and it's in use, R will give you a helpful message that says, I wasn't able to remove it. And it succeeds. It successfully did not remove it. So it doesn't like error out. You have to read the text to understand that, yeah, nothing actually got removed. If you try to install it while it's in use, you'll get a nice little text message that says, oh, I tried to install it, but it was in use, so I couldn't actually do anything. So parse those messages afterwards because it will succeed, it just won't do it, which seems weird. If you have third-party libraries, update.packages will update everything across the board. If you want to update a specific package, install that packages, and that way you can upgrade it specifically. Okay, now I want to pop back to the rest of the story here for SQL Server. I've shown you generation of predictions. One of the reasons why I'm okay with storing models in SQL Server for machine learning services is this concept of native scoring. So using my database, I am going to have another table that will be models that are effectively native scored models. We'll have a new procedure, and inside this procedure, we'll build out a model type, and I'm expecting to get a trained model back. So my SQL command looks the same as before. We're training against this data prior to 2015. The SP execute external script, you'll notice, is a little bit beefier. We're still loading RevoScalar. We're still doing our initial prep work. But now, if I pass in the term dtree, we're going to build that decision tree. And when we serialize the model, we'll turn real-time scoring only equals to true, meaning that we have enabled this for native scoring. Native scoring only works on a few specific model types: linear and logistic regression, decision trees, boosted decision trees, random forest, and there's one other that I'm blanking on off the top of my head, but no neural networks, nothing really fancy for native scoring. Here's my linear regression example where I do RxLinMod. And by the way, you have to use the Rx functions for these. So you can't use LM, which is the built-in R linear regression or linear model. You have to use RxLinMod. But if you do that, what happens is we can generate a model binary and insert that into rental models. So let's do these first three steps just to show you what's going to come out of it. So we're inserting into rental models, and I have my model name, my language, and my native model. This binary, if I take it, I can now generate predictions off of the binary without having to call machine learning services. Even better, I could take this binary, put it on a SQL Server instance that does not have machine learning services installed, and because it is native scoring using one of those 6 built-in models, I can use this predict operator and execute it against a totally different SQL Server that has no machine learning services. So I can build this in a separate server and then bring it to my mainline production SQL Server instance that can't be slowed down for anything. And native scoring is fast. This is only 453 records, so it's hard to tell based off of this, but I've done trials where on this laptop that I have, I've been able to push 120 some thousand records per second. So generating over 100,000 rows per second of data and inserting them into a table, all with native scoring. It is incredibly fast. So I'm a huge fan of native scoring. So now let's look at building our own package, because I talked about that a bit, but I haven't really like dug into the details of what a package looks like. So I have here a project, ski rental project, and we're going to pop open RStudio, loading up this project. I'm going to say no, I don't want to do that. Okay, so I've got my project. Let's go over to files. And I have two files here. There's a hello.r that's basically just a hello world. When you build a new project, it'll give you hello.r by default. I left that in just to give you an idea that, hey, you can build and reload the package using these commands. What I'm interested in is this generate predictions.r. So generate predictions is a function that takes in two things, an input data set and a model. And we load RevoScaleR, we take rentals equals input data set, we convert these to factors. If you're looking at this code and it looks familiar, that's because it is familiar. This is almost exactly the same code as what we had in SQL Server, but I've pulled all of the important guts out of SQL Server, and I'm able to build this package. Coming back to hello.r, Control-Shift-B, I can build it. And once I build it, what I'm going to get some binaries, including ski rental project.zip. So I can take this and I can install the R package. So I've got that right here. I'm going to load SQLML utils. I'm going to connect to localhost.tutorialdb, so different database. I don't have it installed already, so I'm going to install ski rental project. And it says, hey, I successfully installed it. Great. So again, this can be part of our build process. After we've successfully built the R project, we get those binaries, and then a separate R script can run SQLML utils. Once we have it in place, I can create a rental count package call. And now my SQL script looks like this. I declare the model because I still need to get the model and I still need to get the query. But my script is as simple as saying in the ski rental project namespace, call generate predictions, passing in the input data set and the model that we're getting. So now my T-SQL code is almost entirely decoupled from my R code. I can update the R code, I can update that project, it can get more or less complex, and my SQL query, this procedure, does not need to change at all, unless we change the shape of the output or the shape of the input. And once I've got that in place, I can call my package version, passing in input data. Okay, I no longer need this one. So passing in that input data and getting back my prediction. So now my SQL Server procedure is pretty lithe. It's easy to maintain, and if I have bugs in the R code, it's a lot easier to handle that in RStudio than it is in SQL Server. Briefly on security, if you want to execute an external script, you need to have grant execute any external script, or put the user in DB owner or database role or the sysadmin server role. That's obviously a shotgun blast approach. If you want the scalpel, it's a grant execute any external script. Now, that's any external script, which means I can now write arbitrary R and Python code. I can't lock you down and say you're only allowed to execute certain scripts, at least not with ML services itself. Instead, we use what's built into SQL Server for role-based access control. So I can prevent you from reading or writing tables. In 2019, by default, if you don't do anything else, you can't write to the file system. You can't really read from the file system very much. You're limited to certain directories. I can't install packages by default. So I have to be able to be granted those rights to install. Or you may want to lock down stored procedures. So there are things that we're allowed to do to tighten up our environment without the ability to force people only to run certain scripts. Management in a few minutes. If you want to upgrade, in 2016, there was a process. This is the process for 2017. You have to bind a new version of R or Python. So a new version of Microsoft Machine Learning Server, you can bind that to your SQL Server instance. And the way you'll do that is first by downloading the version of Machine Learning Server. Here I've got it from what used to be MSDN is now Visual Studio Downloads. You can also get this from a volume licensing download center. When you run this executable, it's going to ask, do you want to bind this to another SQL Server instance? You're like, yeah, here's my SQL Server instance. I would like to upgrade the version of R and Python on here to the version that is installed with Microsoft ML Server 9.3 in this case. So you have to accept terms. This is for Microsoft ML. You have to accept terms for R. You have to accept terms for Anaconda Python. And then one more button to push. There's a lot of things to check and push. This is the last one. You install, it runs for a while, eventually succeeds, and you have now ML Server 9.3 on your SQL Server 2017 instance. Because, oh, by the way, you have to restart the Launchpad when you're done, just to say, point to this new version of ML Server, not to the old one that you had. Because 2019 is still brand new, there haven't been any ML Server upgrades of versions, so that process might have changed in 2019. I think it's kind of a wait and see what happens approach, but that's the way to do it in 2017. If you want to lock down resource utilization, Resource Governor is good for this. If you're using Enterprise Edition, you can tamp down on CPU, you can tamp down on memory, and prevent your R or Python scripts from completely derailing your SQL Server instance. So Resource Governor has the capacity for regular pools, which is all about your SQL Server connections. So people who are running queries in SQL Server, maybe your developers, you can throttle how much IO they get, you can throttle memory, you can throttle CPU. Well, there's this concept of external pools that is specifically for external scripts, for R, Python, Java. And that way, you can dedicate a certain amount of CPU, RAM, or IO, and also cap that so that if somebody does run a process that's like generating, I don't know, a few 100,000 neural networks, it doesn't run your CPU at 100% for several days in a row. Personal experience, that one. So I do have some demos here. I know that we are getting close to the top of the hour, so I will very briefly talk through Resource Governor. I have an existing pool default with max server memory of 60% is what I'm going to set it to. By default, that is 100% as I recall. Incidentally, I can set my external resource pool to a max memory of 40%. By the way, 60 plus 40, I'm not saying 60 plus 40 equals 100. This is not what we're setting up here. So I could actually set 60 and 80, and both of them are okay. It's just that, you know, obviously if they're both going to compete, eventually we'll get to 100% CPU utilization. This way we cap out at 60 and 40% respectively. If I have resource pools set up, yep, here, this is a brand new installation of SQL Server. So my internal default pool is set up to 100% of max CPU. So I could drop that down and allow the external pool to get a bit more resource. Or, because this is set to 100% right now, actually a bit less in the way of resources. Earlier versions of SQL Server, had this set to 20% by default. I think that might have been a standard enterprise edition thing. I think in developer edition it's 100%, but I would have to double check on that. So it may be at 20%. And I have had cases where running code in production would fail because I needed more memory, especially. And let's run through this. I needed more memory in particular. And as a result, I would run out of memory, query would fail. So bumping up the max memory percent was also useful for me. We can create an external resource pool and say for developers, they only get a max memory percent of 10. You don't get more than 10% of available memory. And that way, we don't have developer queries that are taking down our servers. If I want to classify something, I need to be able to say, yeah, this particular session is a developer session to put them into this dev resource pool. So the way I do that is creating a classifier. And my classifier function will split by the program name. It's going to look for specific program names, like if you're running it in Azure Data Studio, RStudio, etc., you're going to be in my developer workload group. There are other ways that you can determine. Maybe you're using account names. Maybe you're using certain other tokens that you might know about to determine whether or not this is an application user. Perhaps you're using IP addresses. Whatever your method for classifying is, we'll assign the classifier function, and that way, if somebody does come in through Azure Data Studio and runs a really expensive operation, we're kicking off TensorFlow and building a big neural network, we're not going to grind the server down to its knees. And I do have some cleanup afterwards if you're playing along at home. So as far as DMVs go, I have some scripts that I find really helpful. Go check those out. For file cleanup, this was an older thing in 2016 where if you had a lot of queries executing, it would store those files until the Launchpad service restarted. I believe that has been fixed in 2017. We had a problem in 2016, so I do have a note on it. As far as a few general tips as we round out this talk, I found that if you have your data already in SQL Server and you tend to use batch processes for training and scoring, then machine learning services works quite well. If you're able to use native scoring, it works extremely well. The other case that may seem a little weird at first is you want to interact with R and .NET. There is a NuGet package for R.NET. I didn't like it very much, to be honest. This makes your SQL Server a very expensive way of integrating R and .NET, but it's also a viable route. But you have to be in a case where you do not need real-time interactivity because the Launchpad takes time to start up. So if you need that sort of singleton real-time prediction and cannot use native scoring, I would avoid machine learning services. An example of this, we had a process that would categorize inputs and decide what sort of category you were in. So it was a big classifier, a large multi-class classifier, and we needed near real-time results, but people were sending in data 1 or 2 records at a time. So ML services, the Launchpad can take 3-5 seconds to start up sometimes, and that 3 to 5 seconds was just a killer. So we ended up having to put it in a completely different service. We had to just run a Python web server and have that exchange requests. If none of your data is in SQL Server, this doesn't make sense. Your data really has to live in SQL for this to make the most sense, for this to be most effective. I used RevoScalar in the demos here, but you can certainly use classic R functions as well, like lm versus rxlinmod. My bias is actually toward those classic R functions because more people know about them and they're more portable. But if you're able to use native scoring, well, you have to use RevoScalar And if you can use native scoring, I really would push you in that direction. It is so much faster than the alternative. So as we wrap up, SQL Server Machine Learning Services is going to give you the ability to operationalize R and Python fairly effectively. It does have its challenges. We've talked through some of them around security models changing. We've talked about complexities in packaging, and I could always rant about a few other things if you'd like. If you'd like to learn more, go to csmore.info/on/ml services. That's where you'll grab these slides. You'll be able to get my demos and links to additional resources. If you have any questions at all, please feel free to reach out to me. I have an email address and Twitter handle on the screen here. And with that, Mark, if there are any questions, I'd be happy to take them. Sounds like we might not have questions. Okay, so with no questions, I want to say thank you very much for showing up today for the data science virtual chapter, virtual group, and have a wonderful rest of your day.
Kevin.
Hi, now we can hear you, Mark.
Oh, okay. Sorry.
Uh-oh, we've lost Mark again. Okay, sounds like there is a question. Are ML services and database available in Azure SQL database? And if so, which tier? Boy, that is a good question. I believe the answer is yes, but I'd have to check on it. I can tell you for sure, yes for SQL Server on Windows, yes for SQL Server on Linux. I believe the answer is yes for Azure SQL Database, but that's like 60% probability. And as far as tiers go, unfortunately, I'm not sure. I don't do much with Azure SQL Database myself, so I'm not positive where that would be. I'd like to say premium tier stuff, but it could very well be in every tier, so I don't want to get you wrong on that.
Oh, I figured it out.
Great.
So Kevin, thank you for your talk. My audio was freaking out here. I was saying, I really appreciate your talk today. Also, your ability to zoom in and capture all that live is just amazing. I mean, I've seen so many people use Zoom tools, and I'm a lot slower than you are. So kudos for that. Thank you very much for the talk today. We just had that one question. I don't know the answer myself. To see are ML services available in Azure SQL? I don't think the answer is yes. I think it's still no. And part of the reason it's no is because of the way that Azure ML is now being spun up to allow for machine learning to run in its own space with its own compute. So the architecture for Azure is different, and I don't anticipate that that would change. We could talk about the pros and cons of doing it both ways. But certainly for the people who are on-prem, and even when this technology came out, I was really excited to see the Launchpad, the ability to run other languages, because there are other use cases. And let's go back to the bigger story. There's plenty of data still in on-prem. Most of it is there, I believe. Today, I mean, I don't know if anyone has a complete census on that, because Microsoft obviously doesn't have an insight into what people are keeping on-prem. But there is a lot of data out there still on-prem. This topic is therefore still relevant for many people who are running that type of workload for different reasons. So anyway, thank you today for today's presentation, and thanks everyone for attending today. I'm going to stop the recording now.